Okay, good morning, everyone. So last time we was talking about algebraic expression. So we start talking about monomial, then we go to binomial, then trinomial, and we end it by polynomial. And also I gave the definition of algebraic expression. Then we talk a little bit about adding and subtracting polynomial. I gave a small example for adding and subtracting polynomial. Then we move to multiplying algebraic expression. And also I gave a small example for multiplying algebraic expression. So we stop up to special product formulas. So here, special product formulas. So suppose I have A and B. Let A, comma B real numbers, or could be algebraic expression. Algebraic expression. Then I can define A square minus B square equal the first term minus the second term multiplying of the first term plus the second term. This is the first formula. Second one, I can define A plus B, everything square. This is equal the first term square plus plus 2 times the first term, second term, first term, second term, plus the second term squared. Also, I can define third formula, A minus B, everything square. This is equal the first term square minus 2 times A times B plus B square. So look here, if the sign is positive, here must be positive. If the sign here is negative, here must be negative. Give some example, a small example for this. Applying to this formula, example. Suppose I have 3x plus 5, everything square. Who will do this one? And which formula I should use from 1 to 3 and above? Formula number 2. Eric said formula number 2. Okay, can you do it? Can you do the formula? Yes, go ahead.
So it will be 9x squared plus 13x.
So 3x, everything. Hold on 1 second. So I'm going to do it step by step, okay? So the first term, this one, right? 3x squared plus what?
Plus 2 times 3x times 5.
Times 5.
Plus 5
plus
squared.
What? 5 squared. Now we're going to simplify this one. So I like the first section in this book, we can distribute the exponent inside the parentheses. So I get 3 squared, they give me 9.
9x squared.
X squared plus, we multiplying the 2 by the 3 by the 5, so what I get?
13x.
2 times 3 is 6. 6 times 5 is 30. X plus what?
Plus 25.
25. Thank you so much. This is correct. So by applying the second property, a plus b, everything square, I get the first term square plus 2 times the first term times the second term plus the second term square. So again here I can say my a is equal 3x and my b equal 5. Then I'm going to apply the second formula. Apply the second formula. Okay, any question for this one? Okay, another example. Example number 2. 2x minus the square root of y times 2x plus the square root of y. Who will do this one, and which formula I should to use from 1 to 3?
The first one?
First one, this is correct. So if we go back to the first one, I see here a squared minus b squared equal the first term a minus the second term times the first term plus the second term. So if we go back to the example, I see here 2x, and I see in the second parenthesis 2x. And also in the first parenthesis, I see here the square root of y, but I see minus in front. Also, I see here in the second parenthesis the square root of y, but in the front is the plus. So if we go back to the formula, I see here a minus b. I see this part in this formula. The second part, this part, a minus b times a plus b. So this is my a. So I can set here a is equal to x, and my b is the square root of y. Then we apply the formula. So I get here, who can apply the formula? Who will apply for the formula for me? Applying this formula, the first one. We'll do it.
So a minus 2x minus
2x.
minus square root of y.
But in above of 2x, what I see here?
Oh, square.
Square. Yeah, don't forget the square. So 2x to the power 2 minus b squared. So what is my b?
The b is
Square root of
y.
Exactly. Everything square. Then what I get? What is 2x? Yes, 4x squared minus what?
Y.
Minus the absolute value of y. Y. Why is the absolute value of y?
Because square and the
Because I
square root
have,
cancels? No.
because even, I have even power. Like I learned last time, I said, if I see something like this, y to the power n, and I have square root, the nth root, this is equal two things. Y, if n is odd, and the absolute value of y, if n is even. So the even number is 2, 4, 6, 8, 10, 12. All of this even numbers. If n is even, the absolute value of inside under the exponent. If n is odd, I take the y without the absolute value. So here I have 2, the exponent here is 2. Number 2 is even number. And also I have exponent 2. So the 2 with the 2, they cancel each other, but I cannot cancel it and put y. So I should to put the absolute value of y, because the exponent here, the n, is even. Make sense?
Yeah, because isn't it because like the answer could be positive or negative? That's why you do absolute value.
No, not
So-
because positive or negative, because n is even or n is odd. Not because the positive or negative, because the even and odd. The even numbers is 2, 4, 6, 8, 10, 12, 14. And odd numbers are 3, 5, 7, 9, 11. So it's not because the positive or negative, because even or odd. If it's even, I take the absolute value. If it's odd, I don't have to take the absolute value. Make sense?
Can you explain that again?
Okay. So again, if I have the nth root of y raised to the power n, if this n is odd number, this n and n. If n is odd, I take only the y inside. If n is even, I take the absolute value of y. For example, I'll give you a small example. What is the absolute value of y to the power 4? I mean, not y. 5 minus 5 to the power 4 raised, and the root are 4. So the 4 here, the n here is 4, and the 4 is even number. So the value should be the absolute value of minus 5. And the absolute value of minus 5 is 5. So the answer is 5. But if I have some example like this, minus 5 raised to the power 3, and the root here is 3, the answer is only inside, because the n here is odd. Number 3 is odd number. So the answer is minus 5 without the absolute value. Okay. Any other question? So the same things here for the y. Here, the n is 2, and the 2 is even number. So I have to take the absolute value of inside. Okay. Any other question for this? So this is the last things in this section. Now let's go to the new section. Is P.6 Factoring common factors. So first things we have to know, if I have example like this, x squared minus 4, the factor of this one is x, the square root of x is x minus 2. I mean, like applying to this formula, a square minus b square equal the first term minus second term times the first term plus the second term. So we're going to apply this formula, the first formula. I get here x minus 2 times x plus 2. So we should to know, if we go from this side to this side, this is called factoring. This is called factoring. But if we go in the opposite way, like this is called expanding. Expanding. So from this side to this side is called factoring. From this side to this side is called expanding. So, okay, let's give a small example how we can factor equation. So the question is factor each of number 1, 3x square minus 6x. Okay, I'm going to do this one in the beginning, then I'm going to give example for you. So in the beginning, for factoring something like this, we have to factor the first term. So I have here 3x squared. So this is equal 3 times x times x. And for the second term, this is equal, the 6, I can factor it to 2 times 3 minus 2 times 3 times x. Now this is equal. So the common factor between the first term, this term, and this term are the 3 is common factor because it's similar in the both of the terms, and also the x. So now I can say here the common factor is 3x, open parentheses, whatever left here we have to put inside the parentheses. So I get here now x is left from the first term minus, here is left is the 2 only. So this is the factoring, the common factor of something like this. Now I'll give you example number 2. Suppose I have 8x squared minus 4x. Who will do this one?
I'll do it.
Go ahead.
So the common factor between the numbers 8 and 4 is 4.
Okay.
And the common factor between the variable is x. So
Okay. This is perfect. Can you factor it like step by step, like in the first example? Can you show me
that's
how we can factor it?
the way you
Yes.
showed? It's a little bit
Go ahead.
confusing for me. So the common factor is 4x, and then when I divide, yeah, somebody else then, I guess.
Okay, this is correct. But if I want to show it by step, yes, go ahead.
Oh,
Chinesa.
so 2 times 4.
Oh, you want to factor it? Okay,
Yeah.
2 times what?
4
4
times x.
times x. But I can factor the 4, right?
Oh, yeah, that makes
can
sense.
factor. Yeah. Okay, so I get 2 times 2
times
times 2.
Times 2 times x times x
times x times x minus what?
minus 2 times 2 times
2
x.
times 2 times x.
Yeah.
Now, what's the common factor between the both of the terms? Is 2
times, yeah, 2
and 2 also, the other 2,
and then x.
the x. Okay,
Yeah.
so what I can say here, 2 times 2 is 4. Yes, correct. And x,
Mhm.
what's left here?
X, 2x actually, 2 times x.
2x
Yeah.
minus
Nothing.
minus 1.
Oh, minus 1.
Yeah,
Wait,
when it
1?
will be nothing, it will be 1.
Oh, okay, 1.
Okay,
Mhm.
that's it. Thank you. And thank you, Shop. Any question for this one? Okay, another example. But in this example, we don't have to do this step. If you can factor it right away, so you can give me the factor. 2x plus 4 times x minus 3 minus 5 times x minus 3. So what is the common factor between the first term and the second term? Between this and this? What is the common factor between this here and this one?
X minus 3.
Yes, exactly. It's x minus 3. X minus 3. Now we open parentheses. What's left here? This one. 2x plus 4. 2x plus 4. And what's left in here?
Minus 5.
Minus 5. This is correct. So now we can simplify it more. So I can get x minus 3. And inside the parentheses, 2x plus 4 minus 5. I can get 2x plus 4 minus 5. They give me minus 1. And this is the factoring for this example. Any question?
Wait, do you factor it now?
Yeah, I factor it. So look here for the second example, right? You're
No,
talking about the second one? This
no,
example, the third one?
yeah, after you get x minus 3 to x minus 1, the answer, do you like factor, I mean expand it?
No, I did not expand it. So I put this one down. Here I have 2x plus 4 minus 5. Just I do calculation between the 4 and the minus 5. So I get 2x plus 4 minus 5. They give me minus 1. Because 4 minus 5, they give me minus 1.
I understand, but like
Just as
the answer, do you like do you just keep it like that or do you expand it if you want?
I keep it like this. We don't have to expand it. If I expand it, I will get the same answer like this. The
But
question is factoring. Factor.
if
So you
you,
have to go from this side to this side. Factoring. You don't have to expand it.
but let's say if you had 2x minus 4, then you have to expand, right?
If you have 2x minus 4, if you have 2x minus 4, no, you don't have.
Yeah, if it's the minus, don't you have to expand because now there's two different signs, plus and minus.
No, the question is factor, not expand. Expand means you have to multiply this by this, and you have to get the same. This is expanding. If you go from this side to the black one, this is called expanding. but from this side to the red one called factoring. From the black to the red, factor. From the red to the black, expanding. The question is asked about factoring. What does the last bar say? I cannot say it. So the last part here is x minus 3 parentheses times inside the parentheses 2x minus 1. So I have two parentheses, and the first one is x minus 3, and the second one is 2x minus 1. Now we have to learn factoring trinomial. Factoring trinomial. So I mean, we have to learn how to factor something like this. To factor polynomial of the form x squared plus bx plus c. So the factor of the polynomial of the form of x squared plus bx plus c is, we have to open two parentheses. The first parenthesis is x, have plus plus, such that we have here s, and here we have r, such that if we multiply s times this r, should give me c. And if we do summation of s plus the r, should give me b equal b. So actually we have to looking for two numbers. The multiplying of, we have to factor c first of all, such that we have to looking for two numbers. The multiplying of these two numbers, they give me c, and the addition of these two numbers, they give me b. This is n or r. This is r. This is r, not n. Okay, we have to looking for two numbers. The multiplication of these two numbers, they give me c, and the addition of these two numbers, they give me b. So example, explain that by example. Factor x squared plus 7x plus 12. So what's the factoring of the 12? Give me two numbers. The multiplication of these two numbers, they give me 12. So first of all, we have to factor the 12.
4 and 2, no, sorry.
What is it?
So you multiply.
Give me two numbers. Yes, the two numbers multiplying of these two numbers, they give me 12. Any two numbers. Give me any two numbers in the beginning.
4 and 3.
4 and 3.
4 times 3. What else? 6 and 2. Some students told me, Eric, 6 times 2. What else?
But when you add it, it doesn't give you b though. 6 times
Give
2.
me, no, I mean like give me any two numbers. I mean like give me the factoring of a 12. Two numbers, the multiplication of these two numbers, they give me 12.
12 and 1.
12 and 1. What else? That's it, right? We don't have
Yeah,
Another
unless you
numbers.
add negative.
Yeah. No. Negative 12 and negative 1. No, we don't need it.
Something.
So the same things, yes. So I can set here negative 12 times negative 1, for example. Now, what's the summation of 6 plus 2?
8.
8. Is the 8 here the same like B? My B here is 7. Here I get 8. So this is will not work for factoring. So the first one will not work. For the second one, what is the addition of 12 plus 1? Give me 13, right? Is the same as B here? Is the same as 7? No. So this is will not work too. So I have to remove it. Now 4 times 3. What is the summation of 4 times 3?
7.
Is 7. Is the same as B here? Yes, this is correct. So this is my factor. And the same things here will not work too. If we adding minus 12 plus minus 1, give me minus 13. Also, they will not work because in the middle here B is 7. So the only one work is 4 and 3. So the factoring of this one is x plus 4 and x plus 3. So this is the factoring of x squared plus 7x plus 12. Another example. Factor x squared plus 6x plus 9. Who will give me the factoring of 9? Give me two numbers, two integer number. The multiplying of these two numbers, they give me 9.
3 times 3.
3 times 3. What else?
9 times 1.
9 times 1. 9 times 1. What else? 9 times 1, 3 times 3.
Negative 3 times negative 3.
Negative 3 times negative 3. Okay, let's work for this. 9 plus 1. What they give?
10.
10. What I have here? The B.
6.
What's my B? 6. So this will not work. So here x. For the second one, minus 3 plus the minus 3. What they give?
Minus 6.
Minus 6. What I have here in the middle?
Plus 6.
Plus 6. So also this is will not work too. For the last one, 3 times 3. 3 plus 3. What they give?
6.
6 positive. And I have here 6. So this is only they would work. So my factoring for this trinomial is x plus 3 times x plus 3. And this is equal x plus 3 everything square. Any question? Another example. Factor x squared minus x minus x minus 20. What is the factor of minus 20?
Um, 4 and 5.
4 and 5. For minus 20, here we have minus. 4 times 5 is 20 positive. So give me
Yeah.
minus, for example.
-5 and +4.
Yeah, for example, -5, -5, and times +4. What else? What numbers, if I multiply two integer numbers, if I multiply both of them, they give me minus 20.
-2 times 10.
Minus 2 times 10, exactly. What else?
Minus 1 times 10.
Minus 1
Times 10.
minus 1 times 10, they will not give me minus 20.
Oh,
Times
sorry, I mean minus 20. Sorry.
Minus 20 times what? Times 1, for example. Yes. Okay, let's try this. So I have minus 2 plus 10, minus 2 plus 10, they give me what? 8. But here in the middle, I have minus 1. So this will not work. So this one, they will not work. For the second one, I have minus 20 plus 1. This gives me minus 19. And in the middle, I have minus 1. So also, this one will not work. So here, x. For the third one, I have minus 5 times plus 4. And this is equal minus 1. And in the middle, I have minus 1. So this will work. So this is correct. So the factorand for this trinomial is x minus 5 times x plus 4. Any question for this? No question? Okay. Now, let me give you special factoring formulas. Again, we're going to use it during this section. So here's special. Formulas. So the first special factoring formula is the difference of square. A squared minus b squared. This is equal again a minus b times a plus b. This is called the difference of square. Difference of square. Second formula is a plus b, everything square. This is equal the first term square plus the second plus 2 times a times b plus b squared. This is called perfect square. Perfect square. The last one is a minus b, everything square. This is equal the first term square minus 2ab plus b square. Also, this is called perfect square. Perfect square. It's 1, 2, 3. Now we're going to use this 1, 2, and 3 formulas again for factoring. For example, factor 4x squared minus 25. How I can factoring this one by using this special factoring formulas. Which one I have to use for factoring this one?
The perfect square.
The perfect square, I can use the perfect square here.
I think.
What about if I use the difference of square?
You could.
Yeah, so the best things here, like Seth, he said, difference of square is better to use. So I can change this one and I can make it the same as the first formula. So I can write it as 2x everything square minus 5 everything square. So this is exactly like the first one, the difference of square. So now I can apply the difference of square. So this is my A and this is my B. So now I can applying the difference of square as 2x minus 5, close the parentheses, times 2x plus 5. That's it. This is the factoring of 4x squared minus 25. Is it clear? So applying the first formula, a squared minus b squared, I have here, I can change this one to 2x everything squared minus the second term squared, 5 squared. Why this is equal this? Because 2x everything squared, they give me 4x. 2 raised to the power 2, they give me 4. And x to the raised to the power 2, they give me x squared. And the same things here, 5 raised to the power 2, they give me 25. So now, this is my A and this is my B. So I can say here, A again is my 2x and B is 5. So my A is 2x and my B is 5. Then applying the difference of square, A minus B times A plus B. Okay. Another example. For factoring. So example, uh, 3x raised to the power 4 plus 15x raised to the power 3 minus 21x squared. The question is factor. How can I factor something like this?
Common factor would be 3x squared, I think.
3x squared, this is the common factor. 3, 3, 3, yes, this is 3. And x squared, okay. Open parentheses. Now what's left from the first term? This is the common factor. This is
Yeah, 4x squared.
for the first term here, x squared, right?
Yes.
Left. Okay. For the second one,
5x
5x, yes. And the
minus
third
7.
one, 7. This is correct. So x squared plus 5x minus 7. Can I factor this one inside the parentheses? This is trinomial. Can I factor this one? Give me two numbers such that the multiplying of these two numbers, they give me 7, minus 7.
You can't factor it.
Can you give me the two numbers such that the multiplication of these two numbers is minus 7?
-7
What?
and 1.
-7 and 1. What else?
That's it.
What about -1 times 7? -1 times 7. What else? That's it. We don't have more. So -7 times 1 and -1 times 7. What is the summation of this? -7 plus 1.
-6.
-6. What I have here in the middle?
5.
5. So this will not work. What about the second one? -1 plus 7. What's the answer? What's -1 plus 7? 6. So, but what I have here in the middle?
5.
I have 5. So also this will not work. So actually, I cannot factor inside this parentheses. So I cannot factor x squared plus 5x minus 7. So I keep it like this. So the final answer is 3x squared times x squared plus, open parentheses, x squared plus 5x minus 7. Any question for this section? So the section is finished. Do you have any question? For factoring? Okay. I think this section is easy. Now we're going to new section, rational expression. So we finish algebraic expression. We talk about polynomial, and we specify the polynomial for monomial, trinomial, binomial. Then we give some example for how to add polynomial and subtract polynomial, and how we multiplying polynomial, and also we talk about some special factor, like some special formulas. Then we finish the factoring for like we talk about common factor and also a trinomial factoring. Now we're going to rational expression. So I'm going to give the definition of what's the meaning of rational expression in the beginning. So here P this is P7 rational expression. Rational expressions. So we have to know the rational expression is a fraction of polynomial over polynomial. So I can here said rational expression is polynomial is a fraction of polynomial over polynomial. So here polynomial over polynomial. So any fraction of polynomial over polynomial called rational expression. I'm going to give example for how we can define which of the following is rational expression. Is rational expression. So the first example is 2x over x minus 1. Second one is y minus 2 over y squared plus 4. And number 3 is x over square root of x squared plus 1. Okay. So all of them, as we see here, all of them are expression. So you have to ask yourself, is the numerator and the denominator, both of them polynomial? Is the 2x polynomial? Is the 2x is polynomial? It's a binomial, so it's polynomial, right? Because any binomial is a polynomial. What about x minus 1? Is a polynomial? X minus 1 is a polynomial? Binomial, yes, so it's polynomial. So let me remind you, what's the meaning of polynomial from last section?
One or more terms, more than one terms.
Of what? Is the sum of what?
Sum of more than two binomial, or I don't know.
Sum of monomial. So the
Monomial.
polynomial is sum of monomial. The sum of monomial is binomial. What is the monomial? Who will remind you? What is the meaning of the monomial?
Single term.
Can you give me the formula for monomial? I gave a formula, small formula last time for monomial.
Ax squared.
Ax to the power k.
Oh yeah, ax
A
to the
times x to the power k. What is k? What is k?
Number, non-negative number.
Exactly, non-negative number. So it could be 0 or 1, 2, 3, 4, 5, 7. I mean, like integer numbers. It could not be rational numbers. So would be like 0 and any integer numbers. I mean positive numbers. So it's non-negative integer numbers. So I can remind you here the polynomial is, can set here, and in the end I give you the definition, formal definition for polynomial: b and x equal anything of the form a n x to the power n plus a n minus 1 x n minus 1 plus dot 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 a1 x plus a0. This is the formula of polynomial. So here, as we see here, this fraction 2x is a polynomial. Why? Because if we put instead of a1 2 and x here, and instead of a0 0, and all this term is 0, so I can get here a polynomial. What about the second one here in the denominator, x minus 1 is a polynomial? Does x minus 1 a polynomial?
Yes.
Yes, so here actually I have polynomial over polynomial. So this is a rational expression. So here this is a rational expression. What about the second one? Does the numerator polynomial?
Yes.
Yes, this is a polynomial, y minus 2. What about the denominator? Y squared plus 4.
Yes.
Yes, it's a polynomial. So I can say this is also here. This is rational expression. What about this one? Example number 3. Does x a polynomial?
No.
X is a polynomial?
No.
The x here.
Oh yeah, actually I think it is.
Yeah, the x is polynomial. So the numerator is a polynomial. What about
Because
the
it could-
denominator? No. Eric said no.
I think
Brian
yes.
said no. It's not a polynomial. Shop, it's not a polynomial. Why? Because we have here the square root. So the polynomial does not have square root. Look, this is the formula of polynomial, because here we have the square root of x squared plus 1. So this is not a polynomial in the denominator. So actually, all this fraction is not rational expression. So this is not rational expression. Because the square root of x squared plus 1 is not polynomial. Because it's not polynomial, so this will not be rational expression. Now, the second thing we have to know in this section is the domain of algebraic expression. So after we know what is the mean of rational expression, we have to know what's the domain of this algebraic expression. So the domain of algebraic expression. So the domain, I'm going to give you the definition of what is the mean of domain. Then I'm going to give example how we know the domain of any algebraic expression. So this is I'm going to give you the definition. What's the mean of domain? So the domain is a set of numbers or set of real numbers which will make the expression well defined or define. So again, is a set of real numbers that make the expression well defined. I mean, well defined does not have any error. If I plug these numbers, they will not give me any issue or errors. So I'm going to give some example for this to explain how we can find the domain. And in the website, we have a lot of questions asking about the domain of the expression. So here can give you some expression. Okay. Expression. Here is the domain. So the first example, first expression is 1 over x. 1 over x. This is the first expression, 1 over x. 1 over x. Second expression is the square root of x. Third one is 1 over x. 1 over square root of x. So for the first expression, who will give me the domain? What the set can I plug inside this expression and will keep the expression well defined?
I think anything greater than 0. I think.
Greater than 0. Let's check. Can I plug here, like, can I plug any positive numbers here? Like 1, 2, 3, 4, 5, 7, 8?
Yes.
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 Can I plug any negative numbers? Like -5, -6? They will give.
I think you can.
Yes, right? You can plug negatives. Like if you plug negative, they will give answer.
Yes.
Yes, so I can plug negatives. They will not give any error or any issue.
Oh, I think I know. I know. So x was 0.
Yeah. What about 0? Can I plug the 0 here?
No.
1 over 0?
No.
So I cannot plug 0. So the set of real numbers, can I plug in this expression all numbers except the number 0? So the domain will be as all real numbers, all real numbers except the 0. Or I can define it mathematically as x such that x not equal 0. I mean, for this, all real numbers except x equals 0. Because I can plug positives and I can plug negatives, but when I plug the 0, they give me issue. I cannot plug 0. So the only number I cannot plug it inside this expression is the 0. Now for the second one, square root of x.
Is it all non-negative numbers by any chance?
What is that? Shop, can you
Is
repeat
it
what you said?
is it all non-negative numbers?
Non-negative numbers. Okay, let's try. Let's check. Can I plug positive numbers here?
Yes.
Like, yes, so they will not give any issue because square root of 1 is 1, square root of 4 is 2, and I can plug 3, square root of 3, they give me answer. So no issues. Can I plug 0? Sure.
Yes. Yes.
Yes, square root of 0 is always 0. So no problem, no issues. Can I plug negatives here? Like square root of -5 or
You can.
-4?
I don't think you can ever square root a negative number.
Exactly. So I said last time, if this here, the n, the nth root is even like 2 or 4 or 6 or any even number, I cannot plug here negatives. Here must be positive. I said last time, if this, the n, this n, the root n, because here we have even 2. If this is even, here I cannot plug any negative number. Must be positive or 0 only. So I can set here, like Chop said, the domain all real numbers except the negatives. Or I can set mathematically all real numbers such that this numbers is greater than or equal 0. I mean, from 0 to infinity positive. 0, 1, 2, 3, 4, 5. But I cannot plug any negative. So the domain is from 0 to infinity positive. Yes, if it's yes, this is correct. If it's odd, I can plug positive, I can plug negative, I can plug 0. So it will be like the domain all real numbers. The domain will be all real numbers if the root, the nth root is odd number. Nice question. Now the expression 1 over square root of x. So actually,
Only,
this is like the same like this. Yes, go ahead. Yes, Ahmed.
only, only you can have positive numbers.
Only positive
Is that
numbers,
true?
because because in the second one we said we have to block only positive and 0, but 1 over square root of x we have to remove the 0 because we cannot define 1 over 0. The 1 over 0 they will give me undefined. So actually I can set here, uh, I can say the domain is x such that x is greater than 0 without the 0, without the equal, is greater than 0 only. Why is not equal? Because I cannot plug inside the denominator 0. If I plug the 0 in the denominator, they will give me 1 over 0 and 1 over 0 undefined. Make sense? Or I cannot divide by 0, 1 over 0. I cannot divide by 0. So after this expression and this example, we get a small idea about the domain. Now, I'm going to give another example outside this table. So the example is find, and you can find a lot of examples question website too. So now the question find the domain of x to the power 3 plus 4x plus 2. What is the domain for this example? What is the domain for this example? You should ask yourself, which number can I plug inside this expression such that they will not give me any error or issues?
I think you have to do something with B with the 4x. There's a like I think there's a trick you could use that to find to see if the domain is gonna be
I have to check the B. What do you mean for B? Like the 4, number 4?
You have to factor it.
No, we don't have to factor it. Just you have to check. Can I plug positive numbers here in this expression? Can I put, like, instead of x, plug any positive number? Like, they will give me any error. They will give me like some issue if I plug positive here, positive number like 1, 2, 3, 4, 5. Any positive number? Yes, Ahmed. Can I plug positive numbers here?
yeah, you could.
Yes, so I can. So no issue, no problem. Can I plug the 0 instead of x? Like 2 times 0 plus 4 times 0 plus 2. They will
Yeah, you
give me
could.
issue or problem? Yes, you can. I can. No, nothing will happen. No problem. What about negatives? Can I plug negatives here too? Like -1, -2, -3. Can I plug negatives here? They will give me any issue if I plug, like, for example, -1. They will give me undefined. Yes, I can plug negatives. They will give me an answer if I plug negatives. So no issue, no problem. So actually here, the domain would be like all real numbers. I can plug positive, 0, and negatives. No issue, no problem when I plug. So here, the domain is all real numbers. So the domain will be all real numbers. So now let's go to simplifying rational expression. How we can simplifying any rational expression. So after we know the domain, if you need to know more about the domain, just solve the open sign questions. Now, simplifying rational expression. So how we can simplifying the rational expression? So here, by factoring both of numerator and denominator, and then we use this property. This property here. We'll use this property if I have something like this. A times C, B times C. I can cancel the C with a C. The C with the C can be cancelled. And this is equal here A over C. A over B. So equal A over B. We don't have to cross multiply, just we can cancel the C with the C. So I'm going to give you a small example how we can simplifying rational expression. For example, here, if I have something like this here, fraction, and in the numerator is x squared minus 1, and in the denominator is x squared plus x minus 2. So first of all, what is the factoring of the numerator and what's the factoring of the denominator? What is the factoring of the numerator here? X squared minus 1.
I can try. So
Yes.
Can you do the parenthesis stuff where you put like 2 brackets? Yeah.
Yes, exactly. Okay.
And then you put x in the first
X,
one.
X. Okay.
Plus 1 minus 1.
Exactly. This is called the difference of square. The difference of square. So I'm going to go back to show you which formula we used here. The difference, this formula, I think here back. Yeah, this one here. A squared minus B squared. The first term A minus B times A plus B. So the same things here we use. X plus 1 times X minus 1. Now for the second one, this is trinomial, as we learned in the previous section. What's the factor for this one? Here we have minus 2. We have to factor the minus 2. So give me two numbers, the multiplication, they give me minus 2.
Yeah, someone already.
Yeah, minus, yes, here said minus, Eric said minus 2 times 1. Let me try. So minus 2 plus 1, they give me minus 1. And this will not work because in the middle we have plus 1. So this will not work. Give me another number. The multiplication is minus 2 and the summation is 1 positive.
X plus 2 and x minus 1.
X plus 2. So Ahmed said the numbers are 2 times negative 1 because 2 plus negative 1, they give me positive 1. And this is correct. So x plus 2, and here we have x minus 1. Now, second step, we have to use this property, the canceling the common factor. What's the common factor between the numerator and the denominator we can cancel?
X minus 1.
What we
X
yes,
minus
x,
1.
exactly, x minus 1. So we can cancel this one with this one. So now we can find, so the answer will be x plus 1, x plus 1 over x plus 2. So this is the final answer. So step by step, first of all, we're factoring the numerator and the denominator. Then the second step, we have to cancel the common factor. This is called simplifying rational expression. Another example. So example 2. If I have x minus 2 over x squared minus 4, how we can simplifying this fraction? What is the factor for the numerator? X minus 2?
None.
It's
the same, right?
Yeah, it's the simplest form.
Yes, exactly the same. So we cannot factor. It's factored already. So it's x minus 2. Now,
And
what's
for
the factoring for the? Yes, go ahead.
it's x plus 2 times
plus 2.
x minus 2.
X plus 2 times x minus 2. Now, what we can cancel from the numerator and the denominator?
X minus 2.
X minus 2.
So
what
it's
is left?
only 1 over x plus 2.
Yeah. So after we cancel this one, the left is 1, not 0. Some students, they said 0. After we cancel this with this, the left here is 1 over x plus 2. It's not 0. You have to know this is not 0. So here 1 over x plus 2. X plus 2. Okay. So now, so after this two example, we should to know how to simplify any rational expression. So the idea again, we have to factor both of the numerator and the denominator. Then we have to use this property to cancel the common factor. And the final answer is a over b after the cancellation. Any question for this? Okay, small question. What is the domain for this fraction?
Is it -1 and -2? I am guessing.
What about the 0? It's also in the domain, right? If I plug the 0, they will not give me any issue because 0 plus 1 is 1 and 0 plus 2 is 2. So 1 over 2, no problem. Here Eric said all numbers. This is not exactly correct. All
Is it
numbers.
except -1 and -2? Because then
Minus-
it will then oh, actually any number except -2, because then that will give me 0 in the denominator, and
Nice.
that'll
Very
make
nice.
it undefined.
Yes. So should he thinking, like he said, I can plug any real numbers in the numerator. No issue, no problem. So if I plug positive here, will be fine. Negative will be fine. 0 will be fine. But in the denominator, I cannot plug any numbers. So the only number I cannot plug it here in the denominator is -2, because -2 plus 2, they give me 0. And any numbers over 0, it's undefined. So I can set here the domain is all real numbers x such that x is not equal to -2, I mean. Because if I plug the -2 in this expression, I get -2 plus 1, they give me -1 over 0, and anything over 0 undefined. So the issue here for this fraction is the -2. So I have to remove the -2 from the domain, and anything else will be fine. Now for the second example, what is the domain? Can I plug positive and negative and 0? And what's exactly the problem here in this fraction?
Any number but -2?
Exactly the same idea like before. I can plug any real number except the -2, the zeros of the denominator. The zeros of the denominator is the -2. When I plug here -2, I get -2 plus 2, they give me 0, and 1 over 0 is undefined. So I
You
can
can
set here
always,
the domain.
can't you just
Yes, go ahead.
always set the denominator to 0, and
Exactly,
whatever
I
the x
should.
value is?
Exactly, I have to remove the zeros from the denominator. Sometimes the example is more harder. So I get here, for example, the square root in the numerator, square root of x, and in the denominator like x plus 2. So I have to focus and I have to concentrate in the numerator and the denominator. I have looking for the numerator, where is the domain, and the denominator, where is the domain, because sometimes here could not, like in this example, could not be all real numbers in the numerator. Sometimes I cannot plug all real numbers, because here I can plug all real numbers, it's fine, but here I cannot plug the -2, so I can remove the -2. So I mean, like some example is more harder to find the domain, but this example here in the first one and second one It's so easy to find the domain. Just remove the 0 from the denominator, and the numerator, it is accepting all real numbers. So the domain here is x such that x not equal -2. Now let's go to the multiplying and dividing rational expression. So after we learn how to simplify, we can move to how to multiplying and dividing rational expression. So here multiplying. So I have some small formulas for multiplying and dividing rational expressions. So here, so we use this property. The property is if I have A over B times C over D, the multiplication is we multiply A times C over, we multiplying the denominator together, so I get B times D. So when we multiply two fractions, this is fraction and this fraction, we're multiplying the numerator together, A times C, and then we multiplying the denominator together, B times D. So I get AC over BD. I give you example for this. So example, how we can applying this property. If I have x squared minus 25 over x squared minus 9. This is times, sorry, here time x plus 3 over x plus 5. Who will do this one? First things to doing something like this, I prefer, hold on one shop. I prefer to factor both of the numerator and the denominator. I prefer to factor this, factor this, factor this, factor this, because we're going to cancel some of the common factor between the numerator and denominator. Yeah, go ahead, Shop.
So it's for the first part, it's going to be x plus 5 times x minus 5.
Yes, exactly. X plus 5 times x minus 5
over
what?
Over x plus 3 times x minus 3.
Yes, this is correct. X plus 3 times x minus 3.
And that's multiplying x plus 3 over x plus 5.
Multiplying for, yes, x plus 3 over x plus 5. Now we can make it the two fraction, one fraction only. So like this, like one fraction. Now we're multiplying the numerator together and the denominator together. I get x plus 5, x minus 5, and x plus 3. And the denominator is x plus 3, x minus 3, and x plus 5. What is the common factor between the numerator and the denominator? What I can cancel?
X plus 3.
Yes. What else?
X plus 5.
Yes. That's it, right? So actually the answer now equal x minus 5 over x minus 3. So x minus 5 over x minus 3. This is the final answer. So the best way is to factor the numerator and the denominator, then we have multiplying, then you can cancel the common factor. So the answer is x minus 5 over x minus 3. Now for the another example, example 2. X squared plus 2x minus 3 x squared plus 8x plus 16 times 3x plus 12 over x minus 1. Now, what's the factoring of the numerator and the denominator here? I have to look for two numbers. The multiplication is minus 3, and the sum of these two numbers is positive 2. What is the two numbers?
It's 3 and 1.
3 and 1. If I multiply 3 and
Negative
1,
1 and 3, I think. Yeah.
negative 1 and 3. So I get negative 3, and the sum of 3 and negative 1, they give me negative positive 2. So this is correct.
Right.
So I have to open two parentheses. Inside the two parentheses, x plus 3, x minus 1. Now in the denominator, open two parentheses. I have x and x. What two numbers, if I multiply, get 16, and the sum is 8.
Plus 4 plus
Eric said, what is that?
x plus 4, x plus 4.
Yeah, this is correct. So x plus 4, x plus 4. Now here, what's the factoring of this numerator here? 3x plus 12.
3 parentheses x plus 4.
Plus 4, this is correct. This is the common factor. And now what's the factor for x minus 1?
By itself.
Itself, x minus 1. Now I have to using one fraction instead of two fractions. So I have to do multiplication between the two fractions. So I can get here now one fraction only. And this is equal here. X plus 3, x minus 1, x plus 3, x minus 1, 3 times x plus 4. So I will put the 3 here outside, x plus 4, x plus 4, x plus 4. So here x plus 4, x plus 4. And the last parenthesis, x minus 1. Which of this I can cancel? What is the common?
X minus 1.
X minus 1. What else?
X plus 4.
What else?
That's about it.
Right? Yeah,
Mhm.
okay. So this is the only things I can cancel, x plus 4 and x minus 1. So the final answer here
Is 3 times x plus 3 over x plus 4.
exactly 3 x plus 3 over x plus 4. And that's it. Okay,
I
any
have a
question? Yeah, what's your question?
Do you distribute the 3 to the x plus 3, or do you just leave it like that?
Yeah, you can do it. Yes, you can distribute it, or you can leave it like this. So you can set 3x plus 9 over x plus 4, or you can leave it like this. Both of them correct. Any other question? Any question for this? Okay, so next time we're going to talk about dividing Gaussian expression. We're going to stop up to here today, and have a nice day, everyone. See you
Thank
next
you.
Professor,